So in this video, we're going to find the exact value of trigonometric expressions using identities. Okay, so we're given, in this first example, sine of theta equals square root 5 over 5. And we're also told that the cosine of theta is equal to 2 square root 5 over 5. And I want to find the exact values for the four remaining trigonometric functions using identities. So tangent theta, we know from the quotient identity, is sine theta divided by cosine theta. So that's square root 5 divided by 5 over 2 square root 5 divided by 5. Now with fractions divided, keep, change, flip. So keep the numerator the same, change from division to multiplication, and then flip the denominator, do the reciprocal, 5 over 2 square root 5. So 5's cancel, square root 5's cancel, and so what do I have left? I have 1 over 2. So tangent is 1 over 2. Now what do I know? Cotangent from the reciprocal identity is 1 over the tangent of theta. So this is 1 over 1/2, and this is keep, change, flip. So cotangent is 2. All right. Now cosecant is 1 over sine theta. And so that's 1 over square root 5 divided by 5, which is keep, change, flip, gives me this right here. And so what's that going to be? Well, if I'm multiply through here by square root 5 on the top and bottom to rationalize, I get 5 square root 5 over square root 5 times square root 5 is 5. This simplifies to square root 5 here. Okay? The last one is secant theta, which is another reciprocal identity. It's the reciprocal of cosine, so that's 1 over 2 square root 5 over 5, which using keep, change, flip gets you 5 over 2 square root 5. Multiply top and bottom by square root 5. I get 5 square root 5 over, okay, that looks like 2 times 5, and so the 5's cancel, and I get square root 5 over 2. Okay? So that's for that first type of problem. Okay, let's do one. All right, so find the exact value. And say I had like the tangent of 20 degrees minus the sine of 20 degrees over the cosine of 20 degrees. Well, what do I know about sine of an angle divided by cosine of an angle? Well, we know that this is equal to tangent. Remember, tangent theta is sine theta over cosine theta. So this is really the tangent of 20 degrees minus the tangent of 20 degrees. And a number minus itself is still 0. Cool. Now the next one, okay, the next one is sine squared pi over 12 plus 1 over secant squared pi over 12. Okay? All right, so 1 over secant is actually cosine theta. Cosine theta is 1 over secant theta. They're reciprocals of each other, right? Okay. So if I square it, then I can square it there, and we're still good to go. So this is really sine squared of the angle plus cosine squared of the angle, the same angle. Well, what do I know? Well, I know from my identity that sine squared theta plus cosine squared theta equals 1. No matter what theta is, this is equal to 1. So I don't care if this is pi over 12 or 2 pi or whatever the heck it is, this is still going to equal 1. Okay? Now let's try another one. All right. Let's see here. Let's do this. Let's find the sign of negative 3 pi over 2. Sine of negative 3 pi over 2. Well, what do we know about sine? Sine is an odd function, so the identity, we have the sine of a negative theta equals negative sine of positive theta. So this is equal to negative sine of 3 pi over 2. So if I draw a picture, okay, 3 pi over 2, so here we're at 0, pi over 2, pi over 2, pi, and then 3 pi over 2. So what is the y value down here? Okay, so the y value down here, that's 0, negative 1. So this is negative 1, so it's negative 1 makes a positive 1 right there, okay? And if you think about it, all right, since this is negative, that's rotating in the clockwise, so I would rotate in the clockwise until I got up to here, and that's why, this value is actually 1 here. Okay, cotangent negative 3 pi over 2. So cotangent negative 3 pi over 2. This is an odd function. This is an odd function. So this is negative cotangent of 3 pi over 2. Now cotangent, remember, this is going to be cosine of 3 pi over 2 divided by sine of 3 pi over 2. And so if I'm looking at 3 pi over 2 here, the cosine is 0 and the sine is 1. So this answer here is 0. All right. Hopefully that kind of helps you out in using identities to help you evaluate, okay? Evaluate these trigonometric functions given their degrees or angles and radians.